Hello and welcome to Train Signal. You're watching Performance Optimization with Distributed Resource Scheduler. In this lesson, I'll be providing an introduction to DRS. We'll cover the DRS requirements. I'll cover resource pools, how to create a DRS-enabled cluster. We'll discuss HA and DRS cluster settings. And then finally, we'll end the lesson with creating resource pools in your DRS cluster. So with that, let's get started. Before I define what DRS is and what it can do for you, first let's step back and picture a new virtual infrastructure that you created. You're consolidating your physical servers into it, you're consolidating end user desktops into it. More and more the number of virtual machines is growing, and the utilization of those virtual machines continues to grow. And all this is growing disproportionately. In other words, you've got multiple ESXi servers, you've got multiple virtual machines. When you go to add a new virtual machine, which ESXi server do you place it on? How do you know if one of your ESXi servers is overloaded while another ESXi server is underloaded? And think about it, these virtual machines and the applications and demands inside of them are constantly expanding and contracting throughout the day, week, or month, depending on how the end users are using these applications. So over time, how are you going to balance this constantly fluctuating load across multiple ESXi servers within your virtual infrastructure? Well, DRS is the answer. VMware's DRS, or Distributed Resource Scheduler, doesn't actually stand for Dynamic Resource Scheduler. It stands for Distributed Resource Scheduler, and DRS understands the resources of the virtual infrastructure. That's its job. It knows about CPU, memory, power, and storage utilization. DRS ensures that a virtual machine gets the resources that it needs. So it's not load balancing. It's not trying to just make sure that every ESXi server has the exact same CPU utilization. What it does is it's looking at the resource requirements for the virtual machine. It checks to see if that virtual machine is getting the resources it needs from the current ESXi server that it's on. If it isn't, it considers moving it to another ESXi server where it might be able to get the resources that it needs. And it doesn't consider that lightly. It considers it over time, and it also considers the performance penalty to moving that virtual machine to the other ESXi server. Now, it doesn't just work with existing virtual machines, it also works with brand new virtual machines. So when you create a brand new virtual machine, DRS can be used to automatically place that virtual machine on the right ESXi server. And oh, by the way, when it moves running virtual machines from one ESXi server to another, it's using VMware's vMotion, so there's no downtime to that application and to the end users using that virtual machine. In other words, it can do this without causing any downtime. It can balance the load, and there should be no noticeable impact to the end users. And to me, that's the most amazing thing about DRS. Never before have you been able to dynamically move virtual machines from one host to another, completely automatic, in the middle of the night while you're sleeping. DRS is on the job, and it's ensuring that the virtual machines get the resources that they need. That's a really great feeling for a VMware admin. So this is what it looks like. This is a graphic from VMware.com. You've got multiple ESXi servers on the bottom, your physical ESXi servers. They're part of a DRS cluster. You can have clusters without DRS or HA. You can have clusters with just DRS, clusters with just HA or high availability, or you can have clusters that have both, Distributed Resource Scheduler and high availability, all in one cluster. So once the virtual machines are in this DRS-enabled cluster, if they aren't getting the resources that they need, DRS is going to dynamically move them from one host to another without any downtime, again, to the end users. So here's another way to think of it. The hosts and clusters are providing the resources, and the virtual machines and their applications inside are consuming the resources. So the goal of the Distributed Resource Scheduler is to prevent one virtual machine from monopolizing all the resources. It's also to guarantee the service levels that the virtual machines need for your business to survive, for your business to get adequate performance and response out of the virtual infrastructure. DRS is there to guarantee that service. It's also there to offer efficient use of the server hardware, so you're not maxing out one physical server while another physical server is sitting over here with 10% utilization. And finally, it's going to make your life as a VMware admin easier because you don't have to worry about these things as much once Distributed Resource Scheduler is in place. Like I said, DRS is enabled on a cluster, and there's multiple automation levels. You can use the manual automation level, which is really just suggestions. DRS actually doesn't move anything. It just says, hey, I really think you should move this virtual machine from this host to this host. Then there's partially automated, which is really just automatic placement. So when you power on a new virtual machine that you just created or one that was there for a while, whenever you power it on, it's automatically placed on the correct ESXi server that has the least load. And then it's going to offer you suggestions about load balancing. And then there's fully automated, which is going to completely automate the distribution of these resources to the virtual machines, and you can actually set a migration threshold is what it's called. So basically this is just the tolerance for DRS to determine how aggressively it should be about migrating virtual machines from one host to another. You can create custom migration rules to keep virtual machines together or apart, and DRS can automatically place new virtual machines in the cluster. That's part of the DRS cluster once it's enabled. So what are the requirements for DRS? Well, you need either vSphere Enterprise or Enterprise Plus licenses. You also need shared storage between the hosts, just like with vMotion. Many of these requirements are the same as vMotion because DRS is actually using vMotion. So you need that shared storage, and you need CPU compatibility. All virtual machines in the cluster must be on that shared storage. And one of the best ways to see if DRS is going to work is to just try a manual vMotion from one ESXi server to another to see if vMotion actually works. That's going to test the CPU compatibility and the shared storage. You need to be aware of those CPU compatibility issues, and you also should consider enhanced vMotion compatibility if you have multiple servers from the same manufacturer but from different CPU families. You should also check out the DRS tab and Resource Allocation tab on the cluster, and that's something I'll show you here in just a minute. So without further delay, let's go over to our vSphere client and let's get started creating our first DRS cluster. Here in the vSphere client, to use DRS, it's really not that hard. So you've got vCenter at the top level here. You've got your virtual data centers. All you need to do is to right-click here, and let's create a new cluster. You could also use Control-L. So I'll create a new cluster, and then you have to give that cluster a name. So let's say that this is going to be both an HA and DRS cluster. I'm just going to call it HA/DRS cluster. And then in our case, you can check to turn on vSphere DRS right here. You could also create the cluster, move the ESXi servers and virtual machines into it, and then come back later and enable DRS on the cluster. But in this case, we'll go ahead and do it right from the start. So I'm going to check here to enable DRS, and then of course if you wanted to enable VMware's high availability, you would place that check mark right there. I'll leave that unchecked for now because we'll just take one step at a time and enable DRS. From here I'll click Next, and then here's the automation levels that I was talking about. So we've got three different ones here. We've got manual, which means DRS will just make suggestions to you. It won't actually move any virtual machines. That might be good to try from the start, just to see what DRS will do for you, but I think you'll very quickly find that DRS is a reliable and extremely helpful tool, and you'll want to move quickly into the fully automated mode. There's also the partially automated level, which means that virtual machines at power on would be automatically placed onto the right ESXi server for them. And then with partially automated, vCenter would also make suggestions to you related to DRS migrations to recommend that a virtual machine is moved from one ESXi server to another for performance reasons. However, I think that you would very quickly, again, want to move into fully automated. Everyone I talk to out there is using fully automated. I've used fully automated in production for years, and it works great. Then with fully automated, you've got this migration threshold. So the migration threshold ranges all the way from conservative to aggressive. And you can read what each one of these different levels does down here on the bottom. As you see, that description changes as I move the slider left and right from conservative to aggressive. I recommend from the start just leaving it in the middle, and then you can come back and you can read more about these later and consider perhaps making a change. I'll click Next here. And now we're being asked about DPM, or Distributed Power Management. Now, DPM is really a sub-feature of DRS. So to use DPM, you first have to enable DRS, and then that will allow you to use DPM. What DPM does is actually a really amazing feature. What it does is, when the load on your virtual infrastructure is low, it will use vMotion to migrate running virtual machines and actually consolidate them onto many fewer hosts. So then what it's going to do is to put in sleep mode actually the ESXi physical servers that it moved the virtual machines from. So in other words, those physical ESXi servers will be effectively powered off, and they won't be using as much electricity or any electricity as compared to what they were using before when they were running virtual machines. Then, when the end users come in, let's say in the morning, and the demand increases on those virtual machines, the resource utilization increases, DPM and DRS will recognize this. They'll wake up the ESXi servers that were powered off, and then they'll automatically distribute those virtual machines back across all the ESXi servers, balancing the load. And the end users will never know the difference. They'll never know that when they weren't using their applications, when the load was low, virtual machines were consolidated and physical servers were powered off. When they came back in, the physical servers were powered back on, and the virtual machines were reallocated or redistributed across the physical servers. Again, so the purpose of DPM is to save your company money by saving electricity when the ESXi servers are powered off. And it might not seem like DPM could save you a lot of money if you just had, say 1 or 2 physical servers powered off at night. But think about it, over time, over the period of a year, if physical servers were powered off, your company could actually save a lot of money. And think about if you had 200 servers, let's say, that were powered off at night when the demand was low. You could save thousands and thousands of dollars on electricity. So DPM has a very compelling use case for enterprises today, and it's also very easy to enable. Your servers do have to support Wake on Land, IPMI, or ILO so that they can be powered back on or woken up after they're turned off by DPM. But all you have to do here is select this radio dial option here and enable DPM to be automatic. Again, it has the same type of threshold slider down here that the DRS automation level does. We'll just leave it in the middle there and leave DPM automatically enabled when we enable DRS. I'll go ahead and click Next here. And now this section is about EVC, or Enhanced vMotion Compatibility. So like I said earlier, EVC is if you have physical servers in your virtual infrastructure and you want to use these with vMotion and DRS, but these physical servers have CPUs from the same manufacturer, but they're from different CPU families. In other words, if you have one AMD server and one Intel server, and that's all you have, then I'm sorry, you're not going to be able to use vMotion or DRS. But if you have, let's say, 4 Intel servers, 2 are from one CPU family and 2 others are from another CPU family, then enhanced vMotion compatibility is for you, and this is where you would enable it right here if it was an Intel server, and then you can specify the CPU family mode. I won't go into a lot of detail on that right now. We've got a whole separate lesson available from TrainSignal on understanding enhanced vMotion compatibility. Since I have 2 Intel servers with the exact same CPU, in fact the exact same model of server, I'm lucky in the sense that I don't have to use EVC. I can just leave it disabled. I'll say Next here. And now the final question in enabling DRS is, do we want to store the swap files in the same directory as the virtual machine? VMware says this is recommended, and in fact I've never done it any other way. So I'll just say Next here and say Finish. And now we just created our new HA-DRS cluster, as you can see up here. Of course, DRS is the only thing enabled on it. We haven't enabled HA yet. And when I click on it there, we get a whole new separate set of tabs here. We get a summary tab for the cluster with DRS information over here, the status of our DRS automation level, power management level, DRS recommendations, faults, migration thresholds, and so forth. We can click here to view a resource distribution chart. Of course, we don't have anything in the cluster yet, so there's nothing to view. There's also a link to the DRS troubleshooting guide. But now we have tabs that are related to everything in the cluster. So I could see all the virtual machines in the cluster, all the hosts. I could go into DRS here and check out information related to recommendations, faults, and a history of DRS migrations. I can go to resource allocation for the whole DRS cluster, performance, task and events, alarms, permissions, maps, and profile compliance. All this, again, related to everything in the cluster. So it's a whole new management layer for your virtual infrastructure. But first, we need to move ESXi servers and virtual machines into the cluster. So far, nothing's in the cluster and nothing's going to happen until we have hosts and virtual machines in place. So to move hosts and virtual machines into the cluster, all I do is select one. I'll select a ESXi server, click on it, hold down, drag it over, and drop it into the DRS cluster. And here it's telling us that the destination for the selected host is a cluster with DPM enabled, and basically just giving us a warning that, hey, this cluster has DPM, it could put your physical server to sleep and power it off, actually, and if you don't have the right hardware features, it won't be able to power it back on. So that's a concern that you need to be aware of since you've enabled DPM. Now, if we didn't enable DPM, you won't get this pop-up message at all. I'll say OK there. And then a quick wizard comes up here related to adding the host to the cluster, and it wants to know what resource pool we should use. Now, when you create a new cluster, there's actually a hidden resource pool, or like a default resource pool. And that's the resource pool that you see when you go to the Resources tab for the cluster. I usually put all the host resources into that resource pool, but you can get more complex and you can create new resource pools for different things. Let's just take the default, but that will actually remove any resource pools that are already on that ESXi server. Now, in our case, it's a brand new ESXi server with no resource pools, so it really doesn't matter. I'll click Next here and Finish. And now we can expand out the resource pool, and we have one ESXi server in the pool. Now, I've got another ESXi server here that has actually virtual machines running on it. In fact, our vCenter virtual machine is in the cluster, so is our Active Directory DNS server. Again, I'll do the same thing. I'll click on it, hold down, drag it over, and drop it into the cluster. We get the same DPM alert here. I'll say OK. And we get the same question about the resource pool. I'll click Next and Finish. And now that ESXi server and its virtual machines are all part of the new DRS cluster. And now we get some more information in these screens. We can see here that DRS is enabled. It says it's on. HA is off. EVC is disabled. We have the total amount of CPU resources, memory, and storage available to this cluster. We can see there's 2 hosts and 8 processors in the cluster. There are 0 data store clusters, but there are 4 data stores. There's 5 virtual machines, and so far no migrations have occurred using vMotion. So within this cluster administration screen, now we can go to virtual machines. We see our list of virtual machines in the cluster. We see our list of hosts in the cluster. We can go to the DRS tab and see if there's any history in here, anything that DRS has done since it's been enabled. And in fact, it looks like one of our ESXi servers was just powered off using DPM. So as you can see here, I have a very low load. I just have 2 virtual machines running on one physical server. I've got another physical server really that was just sitting there. And since I didn't enable VMware's high availability, DPM was enabled when I enabled DRS. DPM said, hey, you're not using that host. Let's just power it off, and we can always power it back on later. So now you see the little sleepy moon over here next to the server, and it's actually grayed out. That means that server's actually powered off because I have one physical server that's able to support the load of my 2 virtual machines running on it. So hey, I'm already saving money with DPM, and DRS is here in case these virtual machines really spike up or I start to add more and more virtual machines on this host. It'll actually power on that other ESXi server, and then it'll use DRS to migrate those virtual machines without any downtime and balance the load to ensure those virtual machines get the resources that they need. I can go to resource allocation here. This is where I manage the default resource pool in my new DRS cluster. The performance tab is now related to everything in the cluster. Then I have a consolidated tab for tasks and events, alarms, permissions, maps, and profile compliance. If we go back here to the DRS tab to recommendations, I'd like to say that I could very quickly demonstrate DRS for you. But unfortunately I can't, because DRS is something that just takes time. You can sit here for quite a while, you could power up different virtual machines and try to push DRS into not only powering on that other ESXi server, but actually migrating virtual machines over there. But I can tell you when it happens, again, there's no downtime, and all that you see is on the bottom task window down here, you'll actually see that virtual machines are being migrated using vMotion. and you'll see that in the history as well. So there's not a lot to see. DRS is really one of those amazing tools that just kind of works in the background, and it's something you don't have to think about. It just really takes care of itself. That's the best kind of load balancing, and the best kind of feature that you can get is one that really doesn't require any maintenance. So at this point, we just finished configuring a new DRS resource pool, and everything looks to be in good shape here. So let's go back to our slides and let's learn more about resource pools and resource allocation. I talked about how when you create a DRS-enabled cluster, there's a default resource pool, sort of a hidden resource pool underneath the cluster. And that's actually what you're tweaking when you go to the Resource Allocation tab on the cluster. But there's multiple ways to reserve resources in vSphere, even if you're not using Distributed Resource Scheduler. You can create a standalone resource pool outside of the DRS cluster. You can create resource pools underneath the DRS cluster. Or even if you don't create a resource pool, you can just go to an individual virtual machine and you can assign a higher priority to that virtual machine, giving it more resources than other virtual machines. There's different ways to allocate resources in vSphere, and the first one is to use a resource reservation. This is where you reserve a certain amount of CPU or memory for a particular virtual machine or for an entire resource pool. The second way is a limit, so you're setting a maximum or an upper bound of resources that this virtual machine or the entire resource pool can use. And then third, you can assign shares for CPU or memory resources to a particular virtual machine. And you can set a high, normal, low, or a custom amount of resource shares to an individual virtual machine. Again, these are for CPU and RAM. And then you can even set storage-related share values. So you can set a maximum number of IOPS per virtual machine. So that's effectively an IOP limit per virtual machine. And then you can also set storage shares. So the high, normal, low, or custom amount of storage shares. So particular virtual machines can be weighted to receive a higher amount of the storage queue or access to the storage. And those are typically used when you use Storage I/O Control or the new Storage Distributed Resource Scheduler. So now let's go over to our vSphere client and let me show you how resource pools and resource allocation works in vSphere. Here in the vSphere client, let me show you some different ways to allocate resources. The first way would be to create a resource pool. So if I right-click on the cluster, or it could be just a particular host, even if you're not using DRS clustering, I can go here to New Resource Pool. So I could assign this resource pool a name. Let's call it Web Servers. And then here I could say that this resource pool, when it comes to CPU, gets a higher amount of CPU priority, a higher number of shares for the virtual machines in the resource pool. I could set a reservation, let's say, so that a particular amount of megahertz are reserved from the host in this cluster to the virtual machines in this resource pool, so that those megahertz are always available should the virtual machines in the resource pool need them. I can set limits, so I could say a maximum amount of megahertz could be used, let's say, by the virtual machines in the resource pool. And then I can do really the exact same thing with memory, but instead of setting a reservation for megahertz, I could set a reservation for memory. And then instead of setting a limit for megahertz, I'm setting a limit here for memory as well. So that's one way to reserve resources. So I could create this resource pool. Here it's called Web Servers. And then I can drag and drop virtual machines into that resource pool. And then suddenly their resources are controlled really by the resource constraints I put on that resource pool. So now this resource pool is really a management unit in the virtual infrastructure. So I can go to the resource pool, I can see a summary for the resource pool, and I could get a lot more detailed information here about resource allocation, both in the summary tab and then as well as in the resource allocation tab. This is actually where I can go in and I can allocate individual resource allocations per virtual machine. Of course, this is something I could also do up here at the DRS cluster level. So I've got a resource allocation tab here, and then I can go to these individual virtual machines. I can go to the CPU view here, and then I can allocate a higher number of shares to a particular virtual machine. It's very easy to do. You can see suddenly that virtual machine has a higher number of CPU shares. I can go to memory here. I can do the same thing, and give this virtual machine a higher number of memory shares. So when that virtual machine went from normal to high, you can think of it as getting twice as much of the memory that's available in this DRS cluster. So that's one way to do it. And then another way to do it is even you can click on an individual virtual machine, even if they're not in a DRS cluster, and you can go to Edit Settings here, then go to the Resources tab, and then do the same type of resource allocation on a per virtual machine basis. So I could do it for CPU, for memory, and for disk. So the disk shares here work the same way. So I can allocate a high amount of disk shares, and then I can set a specific amount of IOPS that this virtual machine would be limited to as it's accessing the shared virtual storage. All right, so that's the basics of resource allocation in vSphere. You've got resource pools that you can create. You could create those under an ESXi server or under a DRS cluster. You've got the hidden or default resource pool in the DRS cluster if you're using DRS. And then you can make resource reservations, limits, and then tweak the share priority on virtual machines, either individually or in resource pools, and do it by CPU, memory, and storage. Now, for additional information on Distributed Resource Scheduler and performance tuning in vSphere, there's a couple great resources I just want to quickly point out. One is Duncan Epping and Frank Denneman's book that just recently came out called VMware vSphere 5 Clustering Technical Deep Dive. It's available in ebook format, and it's also available in a physical real book format from Amazon.com. And it's all about Distributed Resource Scheduler, resource pools, and VMware's high availability. So it's an excellent resource if you really want to get very technical on those topics. Another resource to get very technical on vSphere performance is my VMware vSphere Performance Monitoring course from TrainSignal. I spend countless hours going into Distributed Resource Scheduler, breaking it, fixing it. I go into resource pools, resource tuning, do it from the command line and the GUI. So those are a couple great resources if you want to spend a lot more time and get a lot more in-depth with Distributed Resource Scheduler and resource pools. And that brings us to the summary for this lesson on using VMware's Distributed Resource Scheduler, or DRS. I started off with an introduction to what DRS is and how it can help you. In my opinion, it's one of the most powerful features of vSphere because it has the ability to automate the balancing of virtual machine load across the virtual infrastructure. It does that using vMotion, so it does have some specific requirements like CPU compatibility between hosts, or you can use EVC, and then all the virtual machines have to be on shared storage that the ESXi servers can access. So because it uses vMotion, there's no downtime to the end users using the applications on those virtual machines. And then Distributed Resource Scheduler can automatically place virtual machines when they're powered on hosts that are going to give them the best chance of getting the resources they need. Then it can also balance virtual machines that have been running for some time by moving them to other ESX servers where they can get the resources they need if they're not getting those resources on the hosts that they're currently on. I walked you through enabling a DRS cluster. I showed you the DRS automation level and the migration threshold. And we even enabled DPM, or VMware's Distributed Power Management. DPM has the ability to consolidate virtual machines onto fewer ESXi servers when the load on the virtual infrastructure is low, and then power those ESXi servers off to save you electricity and money. When the load increases, let's say in the morning when the users come back on, the virtual machines can be automatically distributed across those ESXi servers once they're powered back on by DPM. From there, I helped you to understand resource allocation in the virtual infrastructure using resource pools and things like reservations, limits, and shares. Thanks for watching this lesson on using Distributed Resource Scheduler with vSphere 5.